topic is very interesting. That is a reversible reaction and the dynamic equilibrium. So let's see what is the relationship between the reversible reaction and the dynamic equilibrium, or how we can relate the dynamic equilibrium with the reversible reaction. So let's start the introduction. Whenever there is a chemical change, we have see that whenever there is a any type of chemical change or the chemical reaction takes place, we see that the reactants are changes into the products. And we have learned that when the reactants are going to change into the products, this reaction we call it as the forward reaction. And when the products are going to change back into the reactants or the original reactants, this process is known as the reverse reaction. So the reactants are going to change into the products and products are going back change into the reactants. So this is the reaction that is known as reversible reaction. That is known as reversible reaction. And the chemical reaction also having this unique type of equilibrium, having unique type of equilibrium, the equilibrium where the concentration of the reactants becomes equal to the concentration of the products. And we have a lot of examples in our daily life in which where the concentration of reactants becomes equal to the concentration of the products. And this can also be considered by simple examples from the reversible dynamic chemical reaction, as the reaction where there is a dynamic equilibrium and the reaction is reversible reaction, it is known as reversible reversible dynamic chemical reaction. So this statement is very important to understand the concept of reversible reaction and the dynamic equilibrium. This is known as reversible dynamic chemical reaction, the reactions that are going to involve in this process. So next we have reversible reaction and the dynamic equilibrium. Let's suppose one example. We have H2, it is going to react with the iodine I2, forward reaction, and then we have reverse reaction, 2 hydrogen iodide. Let's have their physical states. Hydrogen is in the gas phase, iodine is also in the gas phase, and hydrogen iodide we again in the product it is also in the gas phase. So when hydrogen and iodine combine, this reaction is known as the forward reaction, and when hydrogen iodide decomposes into the hydrogen and iodine back, this process is known as reverse reaction. So this is the simple example of a reversible reaction. We have seen that when the hydrogen and iodine are going to combine, this is the forward reaction. Forward reaction. And when the hydrogen iodide decomposes and changes into the reactants, this process is known as reverse reaction. Reverse reaction. And we see that when the rate of this forward reaction becomes equal to the rate of reverse reaction, this state is known as the dynamic dynamic equilibrium state. Simple, this is known as the dynamic equilibrium state, and we always can gain the dynamic equilibrium state in a reversible reaction. If we have a reversible reaction, then we can gain the dynamic equilibrium in this reaction. We cannot gain the dynamic equilibrium in the irreversible reaction. So that's why This is the particular reaction in which at the initial hydrogen and iodine are going to combine and forming the hydrogen iodide. And after some time the hydrogen iodide started to change into the hydrogen and iodine. So this is a simple reversible reaction in which the reactants are going to change into the products and the products are again changing into the reactants. So this is the reversible reaction, and the time when the rate of these two processes becomes equal, this is known as dynamic equilibrium. So we can gain the dynamic equilibrium only in a reversible reaction. We cannot gain, so I'm going to write that we cannot gain the equilibrium state in a irreversible reaction. Irreversible reaction. So this is the main thing that you must remember, that we can gain the dynamic equilibrium state in only in a reversible reaction but not in the irreversible reaction. Next we have example of the dynamic equilibrium. For example, here we have two systems. The first one system is a open container, and the second we have a closed container. Okay, the A one is a open and the B one is a closed container which is having any volatile solvent, which is having any volatile solvent. And volatile mean the substances that changes into the vapors easily. These substances are known as volatile substances. In the A picture we have seen that when the substances or the liquid started to change into the vapors, and these vapors started to escape in the atmosphere. But in the picture B, as it is a closed container, so these vapors do not get the space to move out. So they cannot move out in turn. They started to gather over there, and after the gathering they started to recondense or recombine and started to change into the liquid. It's mean first the liquid is going to change to the gas phase or the vapor phase, and these vapors in the container A or the first one container escaped to the atmosphere. But in the container B we have seen that the liquid changes into the gas phase or vapor phase. Now these gas phase or vapor phase again condensed back and changes into the liquid phase. So the rate of these two processes becomes equal. The rate of vaporization becomes equal to the rate of condensation. This state is known as chemical equilibrium, or we can say that dynamic equilibrium state, and this is a reversible process. So a simple example we have discussed related to this dynamic equilibrium and reversible reaction. I hope you guys understand about this, and if you have any queries you can ask me about that in the comment section. For that time, have a good day and Allah Hafiz.